Hello, I'm Corentin Bernard from Aix-Marseille University, and I will present the paper Detection of friction-modulated textures is limited by vibrotactile sensitivity. Now, with surface haptics, we can render various haptic feedback on human-machine interfaces. But the design of precise stimuli is not straightforward, and we still need to better understand how these synthetic textures are perceived. In this study, we focus on the perception of ultrasonic friction modulation. Here is a typical signal that we can render with this technology. As the user moves his finger, the friction is alternatively increased and decreased. We can sum up this kind of elementary signal with two parameters, the spatial period and the amplitude. If we reduce the amplitude, at some point, we won't be able to feel the texture. That's the detection threshold. In the present experiment, we investigate how the detection threshold is influenced by the spatial period. But if we look back into the literature, we can find two kinds of tactile thresholds. The first one is for the perception of real reliefs. It says that as the spatial period decreases, we are able to detect smaller bump height. The second one is for the perception of vibrations. It shows a U-curve with an optimal sensitivity around 200 Hz. We can wonder which of the two is in line with the perception of friction-modulated textures. But as you can see, the two abscissa quantities, the spatial period and the frequency, are not the same, so they are difficult to compare. So what's the link between the two? If we take this texture here, explored with a certain velocity, it leads to vibrations that propagate into the finger. Now, if we take the same texture but explored with a velocity twice as fast, it leads to vibration frequencies twice as high. With what we saw previously, we can try to predict the result of our experiment with these two hypotheses. With the first one, if the threshold of friction-modulated gratings are the same as the real reliefs, it would lead to threshold curves that are independent with the finger velocity. And the vibration frequencies at the threshold level would be different. With the second hypothesis, if the threshold of friction-modulated gratings are the same as vibrations, it would lead to threshold curves with a different shape, and the thresholds as a function of the spatial period would be dependent on the finger velocity. If you want to know which of the two hypotheses was confirmed by your experiment, please come see my poster. You may be also interested to see the first sensor that we designed based on an interferometer to measure friction variation with a better sensitivity than a human finger.